So hello, today's video is on quantum computational finance. In particular, we're exploring the question, can quantum computers be useful for computational problems in finance? And the focus here is on problems that appear in capital markets. So some of the directions that have been explored for using quantum computers for financial problems are given here. The first direction are Monte Carlo-based algorithms. In particular, these have been explored for pricing of financial derivatives, for risk management and value at risk calculations, among others. The problem here is to essentially compute an expectation value over some function of a stock S under some probability measure Q. For computing this expectation value, we use sampling-based techniques, and to speed them up with quantum computers is one main aspect of this research direction. So what is f, for example, is in a case of a call option, f of s would be a function, nonlinear function like this, where k is the strike price. So moving on to the next direction that has been explored, portfolio optimization. Here various directions have been explored. The simplest direction is Markowitz mean variance analysis that essentially optimizes a portfolio vector over some assets. So you have been given a set of assets and you can then allocate your money into the different assets. You describe that allocation by a vector, W, and here W is unconstrained. So let's say we have the assets, so we can allocate a real number in each asset. And what we want to do is we want to, given some expected return, minimize the risk. Equivalently, the problem can be formulated given a level of risk, given a risk, maximize the return. This is the first setting, the mean variance analysis setting. Extensions to the setting have been explored. For example, if we constrain our vector W to be only have positive entries, that leads to a second-order cone programming problem, which can also potentially be solved using quantum computers. Another direction is to include integer constraints into the problem. This leads to what is called a mixed integer program. As a third direction, many works have considered the connection of quantum computing and machine learning. Machine learning has many problems such as regression, classification, and clustering. Looking at classification as an example, one can think of, I have already labeled data that consists of two classes of data. Now I'm receiving another set of data, and my task is to classify it to either class A or class B. What the support vector machine is doing is to construct an optimal separating hyperplane between these two data, and then based on which side of the hyperplane my new data is, classifies it to either class A or class B.